Hello and welcome to this video. In this video, we'll learn about total internal reflection. Before we go to total internal reflection, we'll study what is the simple reflection, then refraction, and then we'll go for the total internal reflection. Now let us see what is reflection. Suppose we have a plane surface and let us consider the typical example of glass. Suppose this line, this red line shows the surface of the glass. And now if we consider this material as glass, this is glass, whereas the upper one is the air. Now suppose the light is incident from air to glass. So what we'll do first, we'll just make one normal. We'll just draw the normal, which is exactly 90 degree to the surface. So let me draw with some different color, like say green. This is normal. And with respect to normal, now we'll incident the light. Suppose let us consider the light is incident at say 60 degree, like this. So the light is incident here. So if we consider the light is incident as say A to B, where B is the point on surface. Okay. Let me write B on left hand side here. Now it will get reflected back from this point in air, and according to Snell's law, the angle of reflection and angle of incidence will be the same. So like this. So what we can draw is the same angle as that of the angle of incidence. But if you talk about the refraction, then the angle of refraction will not be the same. It may be different. Now we will count the angle like this for incidence from the normal, okay, for reflection from the normal. So we always draw the angle from the normal. Now if we go for suppose 60 degree, say this is 60 degree, which is expected that it will go in straight line if there is no glass, okay. But since there is a glass, what will happen? This angle will reduce, okay, and it may be, now this angle is reducing, not increasing, okay. This angle is with respect to the, whatever you are seeing is with respect to the surface, and suppose this is 70 degree with the surface, and therefore the reflected light will suppose pass through like this. We are taking a general example. The actual value may be different. Okay. So in this case, this angle is measured from the normal. So like this, from the normal. So this is the angle of refraction, and this is the angle of incidence. Okay, and this is reflection. We know reflection angle is same as that of the angle of incidence. Now there is another rule by Snell's second law, and second law says that the refractive index of the material is given by the sine of angle of incidence divided by sine of angle of refraction, not reflection, refraction. Obviously here sine I is more than sine R in this case, because I is more than R, and therefore this mu will be greater than 1, because this value is more, sine I is more than the sine R. Now we will take the opposite situation. Opposite means in this case, first case, the light was traveling from air to glass. Now I will just take the first medium as glass. And let us consider this situation now. So again we will draw the surface first. Here, suppose this is the surface. Again I will show it with the red. And then we will draw a normal, and normal will be shown by green color, which is exactly perpendicular to the surface. So this way. Now let us talk about, this is a glass and the light is incident, suppose again at say 60 degree. Let me draw very carefully. So this is the incidence. Okay, it should be from top to bottom. And this material, now the upper material is glass. This is glass. And this is air, for example. So now the angle of incidence is in the glass, not in air. So this angle of incidence is suppose 60 degree. And now when the light will pass from glass to air, now this will not go in straight line, or it will not turn or tend towards the normal. It will move away from the normal, and therefore this angle will be something like this. Suppose it is 50 degree. It is not exactly 50 degree, but we will just draw this as 50 degree. Now this is 50 degree with the surface, and therefore this will be about 40 degree from the normal. So the angle of refraction is now more than the angle of incidence. So in this case, what we can write is mu equal to sine I divided by sine R. Now here, sorry, now here the I value is less than R. You can see here, okay, this value is less and this R is more, and therefore sine I will be less than sine R. Obviously mu will be less than 1. Of course, it is not negative. Refractive index will be always positive. Okay, it will not be negative. Now the situation can come where if we increase the angle of incidence, the angle of refraction will also increase. Okay, but it will not be the same thing for certain values. Suppose we increase this, sorry, we increase this value like this. Suppose we make the angle like 40 degree, and let me use some different color. And for 40 degree, obviously, now this 40 is with respect to surface. That means the angle of incidence will be from this point to this point to this 50 degree. Okay, and this angle will be somewhere like this. Suppose you talk about the refraction. So the refraction in air will be like this. Now this has increased. So this is for say green. Okay. Now let me take the third angle where the angle of refraction is now tending towards 90 degree. It is going towards 90 degree, and let us try to find out certain value of the angle of incidence where the angle of refraction is 90 degree, like this. So let me use the red color. Okay. Like this. The angle of refraction is in this direction. So this one. Okay. So this is the third angle that is shown by red. This angle is called as critical angle and it is shown by theta c. Now why critical angle? The angle theta or I will be equal to theta c if angle of refraction is 90 degree. Now this is okay, we can understand that this will be 90 degree. Okay, I will just show like this. What will happen if we increase the angle more than theta c? Now let us try. Let us go for say 15 degree. 15 degree with the surface, not with the normal. So 90 minus 15, that will be the angle that is with respect to normal. Now here obviously if the angle is more than theta c, it is obvious that now suppose this angle of incidence is more than theta c, then r will be more than 90 degree. Now more than 90 degree means you are talking about the angle from this normal, so it will go into the glass itself. So this angle will be something like this. So what is the angle we are getting here? This will be more than 90 degrees. So this complete is more than 90 degrees. And this process where the light is getting into the same medium like glass, that is the denser medium, because of the phenomena called as total internal reflection. Typically it is not a reflection because the angle of incidence is not the same as that of the angle of reflection. You can see here it was when I draw it was like 15 degree to the surface and this was 10 degree to the surface. So they are not same and therefore this is total internal reflection. Even though it is not a reflection, it is a kind of refraction. Okay.